So hello everybody, welcome to my YouTube channel. So in the previous video we have discussed about the linear regression, in which we got that when we talk of linear regression we have equation like y equal to ax plus b, where this y is dependent variable and this a is independent variable. Fine, so this is what we have discussed in the previous lecture, and in today's lecture we are going to discuss about how to find the values of this a and b in this case, so that we can draw a regression line. So let's solve the example. So in this I have considered a few values for x and y. In this case I am considering x as 2, then next value for x is 4, then 6 is there, then we have another value that is 8, and for that case y is 10. So what does it mean over here? It means when x is 2, then in that case y is 3, when x is 4 y is 7, x is 6 and y is 5. So in this case we are given that we have a data set in which a value of x is given and then y is given. Now we will implement this data set for finding the values for this independent variable. So as we know, when we consider the equation y equal to ax plus v, when where a is simply a slope and b is intercept, and then y in this case is these values that is taken, that is yi, and for xi we are having 2, 4, 6 and 8, so on. Fine. So we know we are given this value and this value, but we need value of a and b as well. So now let's write the formula how to calculate the value for a and b. So we are given the formula for that, and in that case let us say how to calculate the value of a. So a is calculated as sigma y, that is sum of all the values of y, x square minus sigma x and sum of product of x and y, and this whole divided by n sigma x square minus sigma x the whole square. And now value for b. So in b the formula is n of sigma xy minus sigma x and sigma y, and in denominator we have n into sigma x square minus sigma x the whole square. So here are the formulas how to calculate a and b in this case. Now in this we need summation of all the y values and the summation of x square and then product of xy ki summation and all. So now if we solve this value, here we need to calculate x square also, because we need this in formula. So let's put all this in table. We need x and y. So when we take x square it is 4, then here 4 for the 16, 36 and then 64, and for xy let us take 3 into 2, 6, 4 7 the 28, then 6 into 5 is 30, 8 into 10 is 80. Now let's take sum of all these. So we will get over here sigma x, that is sum of 2 plus 4 plus 6 plus 8, it is equal to 20, and here we have sigma y, it is equal to sum of all this value, we will get 25 over here, and here we will get sigma x square, which is equal to, if we take sum of this 120, and this sigma of xy, it is equal to 144. Fine. So now we have got all these values, sigma xy, x square and all values. So let's put these values, and by putting this value we will get over here a, that is 25, sigma of y, sigma of x square, it is 120 over here, minus sigma x, that is 20, into sigma xy, that is 144 summation of all the values, divided by 4 into 120 minus 400. So we will get over here 120 divided by 80, and here we get the value for a, that is equal to 1.5. So we got a equal to 1.5. Similarly, we calculate the value for b. We know that n is number of total elements. So in this case, we are having total number of data items as 4. So and we are taking the value of n as 4. Now when we calculate the value for b, we will get 4 into 144 minus 20 into 25 divided by n value is 4 into 120 minus 400. So solving this, we will get 76 divided by 80, that is equal to 0.95. Fine. So we have got the value for a and b. Now when we put these values into this equation, so here we get the value for the next. So we get y equal to 1.5 x plus 0.95. So here we have got intercept 0.95. We have got value of a, that is coefficient for x. This coefficient of for x is 1.5 in this case. Now we have got the equation, that is 1.5, y equal to 1.5 x plus 0.95. So when we proceed further, we will put these values into the equation. So one by one, based on this, we will calculate the value of p, that is the predicted value. So p here stands for predicted values. So when we take the equation and we consider the value, so here firstly 1.5 into x, in this case is, in the very first case is 2 plus 0.95. So solving this equation, we get over here 3.95. Similarly for second value, that is 1.5 into 4 plus 0.95. So here we will get 6.95. Similarly, keep on solving the values, we will get here, and we will get 12.95. So what is this? This is y, predicted y. Fine. So now we have the actual value. So actual value is basically this y, and this is the predicted value. So and now we will try to find the error rate. Error rate in this case. So when we find the error rate, it will be the difference between y, that is the actual value, and the predicted value. So error rate is actual minus the predicted value. So we will take the difference between this, that is between 3 and 3.95. So we get over here 0.95. Here we get 0.05. Here we get 4.95. Here we get 2.95. Fine. So now by using this equation, we have solved the linear regression problem in which we have predicted the y based on these values of x, and we have used the coefficients of x, that is a. We have found that by using this formula, and we have calculated the b. So we have put that into the equation, and by putting the values into the equation, we will get the predicted value and similarly the error rate. Now next thing is, when we have got this value, what we will do next is, we will draw the graph for this on x-axis and on y-axis. So let's plot the graph. So let's take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and similarly for y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So now we have got the values x over here and y over here, Now we will use these values to plot the graph. So let me use different colors in this case. Now for the original values I am going to use green color. Now we know we were given that when the x is 2, the value for y is 3. So when x is 2, the value of y is 3. So let's put a dot over here. When x is 4, y is 7. So when x is 4, y is lying somewhat over here, 4. When x is 6, y is 5. X is 6, y is 5. When x is 8, y is 10. When x is 8, y is 10. So this green color represents basically the actual values. Now we have also done the prediction values. So for prediction, let me use the other color for representation. So I am using red color. So the prediction is when x is 2, y is 3.95. When x is 2, y is 3.95, somewhere around here. When x is 4, y is 7. When x is 4, y is 7. So somewhat over here. When x is 6, y is 9.95. When x is 6, y is 9.95. So some x is 6, y is 9.95, somewhere here. When x is 8, y is 10. So here. So now this red represents the predicted values and green represents the actual values. So now let's draw a prediction curve over here. It goes something like this. And the difference between the actual value and the predicted value over here represents the error rate. This is the error rate in this case. This is the error rate in this case. Similarly, likewise. So this is the error rate also that can be represented visually. So now by solving this equation, we have predicted the value. This is how a linear regression model works, which uses the independent variable to calculate the value for the dependent variable. Fine. So we have calculated those values over here, and then after that, by using those values, we have drawn the plot, the regression plot. Now if you have a look at this, we are getting a curve like this. It can be represented as a accurate curve that is being drawn by the curve. Now suppose that there is if we try to draw a design like this, which is meeting each and every point like this and so on. So this is not allowed, because that will be a problem that will cause overfitting. Fine. So from this graph, we can also visualize whether this is underfitted or overfitted, and we can declare accordingly whether the algorithm is giving or the model is giving the accurate solution, appropriate curve, or it is giving certain problematic curve. So this is how we use the linear regression model to find the equations when we are given the data set having x and y values. And we have discussed the formulas to calculate the value of a and b, that is intercept and this. And the beauty of this is that when this is implemented using Python, then it can be simply be implemented by writing just a small function, that is the linear regression function. So there is another video available on my YouTube channel in which we have discussed, I have shown how linear regression is implemented in Python. So I must suggest you that you should watch that video also, because that will give the practical presentation, practical implementation of the model using linear regression. So thanks for watching the video. If you have not subscribed my channel yet, then you do subscribe the channel, and also click on the notification button so that you may not miss any of the important video. So thank you for your valuable time.